Hello everyone, welcome to another technical deep dive. My name is Cody, and in this episode we're going to provide an overview of location providers and show you how to manage them in the DeepHub. Let's begin by answering the question, what is a location provider in the context of the DeepHub? Because location providers are intrinsically linked with zones, it's important to recall from our previous episode that zones are geographic areas that correspond with locating systems. Zones in the DeepHub are created by georeferencing the ground control points of an area in relation to the installed locating system infrastructure, such as satellites or anchors in the case of an ultra-wideband real-time locating system. Just like zones, location providers relate to the low-level hardware and infrastructure associated with locating systems. Specifically, they refer to the actual positioning hardware that can be tracked by a locating system. Examples include an ultra-wideband tag or a GPS sensor. If a location provider moves within the boundaries of a zone, its corresponding infrastructure and locating engine calculate the position in local coordinates. The DeepHub receives and transforms the local coordinates into geographic coordinates, and a location update is generated for the location provider in the DeepHub. If you have the DeepHub installed, you may work with location providers through the REST API, the WebSocket API, or the UI. Let's start by exploring the UI. Here in the DeepHub UI, the Location Providers tab is front and center, so you can quickly access it to make changes. From here, you can see a list of all of the current location providers in your DeepHub instance, as well as a few key properties. In addition, you can create, edit, or delete location providers, and search or filter for some as well. When creating a new location provider, you'll be prompted to enter information associated with it. It's mandatory to include the ID and locating technology to which the location provider pertains. The ID should be the MAC address of the device or any other hardware-specific unique ID. Other optional fields may be filled out, such as the name, fence timeout, exit tolerance timeout, and exit delay. These properties allow for much greater flexibility in the way fence and collision events may be generated and utilized for advanced location-based use cases. For now, we will leave these fields blank. However, these properties will be explored in detail in a future episode of the series. Subscribe to our channel so you don't miss it. You may also include custom properties that are specific to the application and overall solution in which the DeepHub is embedded, as well as information of the vendor of the location provider. For example, this could include the manufacturer and/or serial number of the device. This approach allows you to pair location information with associated metadata right within the DeepHub, thereby delivering it to any application that requires it. Other examples might include asset IDs or order IDs within an asset tracking solution. Once your location providers are created and configured, they can begin generating location updates, and you will be able to see them moving in the Live View tab of the UI. They are visually represented as solid circles in distinct colors. The colors correspond with the location technology type as shown in the Location Providers tab. In this example, we can see that GPS is purple and ultra-wideband is green. This is also the case if we go back to the Location Providers tab, and we can see that here. If you would like to experiment with the same example, check out our DeepHub example repo on GitHub. The link is in the video description below. The DeepHub REST API supports the 4 standard HTTP methods of POST, GET, PUT, and DELETE. As we can see, it has several endpoints to manage location providers within a DeepHub instance, allowing you to create, read, update, and delete location providers. In addition, there are other endpoints that can be used for more advanced functions based on your requirements. Let's explore a few of these API endpoints. The getProviderSummary endpoint returns an array with summaries of all the location providers in your DeepHub instance. A 200 OK response code indicates the request was successful, and we can see a summary of all of the location providers in my DeepHub instance. The postProviders endpoint may be used to create a new location provider. As previously mentioned, the ID and type parameters are required. A 201 response indicates the request was successful, and we can see the newly created location provider in the DeepHub UI. And here it is, newly created in the UI. The put_providers provider ID endpoint may be used to update a specific location provider. In this example, I will add a name and a few custom properties. A 200 OK response indicates the request was successful, and we can see that the location provider has been updated in the DeepHub UI. And here we are. The location provider has been updated, and we can also see the custom properties as well. You can update the location of a location provider using the put_providers provider ID location endpoint. This API call requires the new position in the form of a GeoJSON point geometry, the source, which would be the zone ID or foreign ID of the RTLS, or the provider ID in the case of a self-localizing device, provider type, meaning the location technology type, and the provider ID. You may also provide other important properties based on your requirements, such as the timestamp generated and timestamp sent, the coordinate reference system, the accuracy, which refers to the accuracy in meters of the location update, floor, this relates to the actual floor upon which the location provider exists, where floor 0 is the ground floor, speed, this refers to the current speed in meters per second, and any other properties. Back in the DeepHub UI, we can see that the location provider's location has been updated. Finally, we may use the deleteProviders endpoint to delete all location providers, or the deleteProviders provider ID endpoint to delete a specific location provider by specifying a valid provider ID. Back in the UI, I'll reload the page, and this location provider will be gone. We've only scratched the surface in terms of what can be achieved with location providers in the DeepHub. There are other API endpoints, as well as a WebSocket API that can be used for more advanced data management requirements, such as manipulating sensor data or combining location providers with proximity events from BLE or RFID technologies. We encourage you to explore these capabilities for yourself and leave any comments or questions down below. Also, please like and share this video if you found it helpful, and subscribe to our channel for more future DeepHub content.